Imagine a credit card database where 99% of transactions are legitimate and only 1% are fraudulent. A simple model that blindly labels every transaction as safe would achieve 99% accuracy. Yet, it fails to detect a single actual fraudster. In imbalanced datasets, standard accuracy is a deceptive metric that hides a model's complete failure. To solve this, we measure precision, which evaluates the quality of positive predictions. Precision asks, out of all transactions the model flagged as fraud, how many were actually fraudulent? Minimizing false positives yields high precision, ensuring users aren't annoyed by constant false alarms. If a model flags 20 transactions but only 10 are genuine fraud, precision is 50%. Conversely, recall measures the model's capture rate, focusing on false negatives. It asks, out of all actual fraudulent transactions in the dataset, how many did our model successfully catch? High recall prevents dangerous misdetections. If there are 10 actual fraud cases and the model detects 8, our recall is 80%. Recall ensures that critical anomalies do not slip through. To balance precision and recall, we use the F1 score. The F1 score is the harmonic mean of precision and recall, meaning it penalizes extreme imbalances. A model with high precision but zero recall gets an F1 score of 0. By looking beyond simple accuracy, the F1 score provides a single, robust score that guarantees your model is both precise and highly effective.